Welcome back. All right, we're keeping the science going. So joining us now is Hunter Tidd, and you study Earth and Environmental Science.
Correct.
Is that the college? It's the College of Earth and Environmental Science.
It's part of the College of Science and Mathematics at Fresno State. We're a department, and we focus on geology and environmental sciences, and we also have a natural science major as well.
Okay, you yourself are a geology major.
Yes.
Okay, so we're learning about soils and sort of how water can make its way through soil, and you've got an experiment for us.
Yes. So what we have here is what we call a flow net demo. And a good way to imagine this in a real life example is the San Joaquin Valley, for instance, or the San Joaquin River to be more exact, is that before Friant Dam existed, is that the San Joaquin River was just kind of running on through. And what happened is we put a dam, and we'll use this wall right here as an example of that dam. And what happened was it created an area of high pressure.
Right.
And so as we see here, this side is a little higher than this side.
Yes.
And so what happens in this area of high pressure versus this area, which is an area of low pressure, is that we're going to see that water is actually making its way underneath the dam.
Under here.
Yes.
It's going this way.
Yes.
Because our dam right here
only goes so far down.
Only goes so far down.
Exactly.
And you were telling me that in nature, things want to be equal.
Exactly.
And so it will force its way to be equal. So how are you going to demonstrate this?
So what I'm going to do here is I'm going to get a little bit of food coloring here.
Okay.
And then with this food coloring, what I'm going to do, I'm going to stick it in a couple spots. I'll stick the first one right here.
Oh, that's kind of sinister looking. I can already see it's making, it's already seeing, like you might think that it might go straight down, but it's not. It's going to, well, my left. It's going to the left. This one's going really fast.
Yeah. So the closer it is, the shorter amount of time it'll get there. A good point of reference if you were to actually.
There it goes.
Yep. And eventually this one will come out and this one will come out.
Oh, it won't even be there anymore.
No, what's going to happen is it's going to move all the way through the subsurface.
Right. And then it's going to express itself up here.
Exactly.
Is this similar? So when I walk on the beach, I'm originally from Ventura, and I step on tar on the beach. Is that similar to oil expressing itself to the surface?
You could say that in a way that it's an idea of pressure.
Right.
And so as things are coming down further, there's more and more pressure. But as you come back towards the surface, there's less and less pressure.
There's less pressure. And when do we see this occur in nature?
Anywhere, to be honest. I mean, you can see it at many of the dams that are along the entire Central Valley, from the Friant Dam to Terminus Dam for Lake Guia and so forth. As long as what we call the subsurface here is porous enough.
Right.
Because as you can see, this is sand, so it's going to travel pretty quickly, pretty fast.
Yeah.
But what will happen is if it's not as porous, it'll take a little bit more time, or it won't move at all. Because other things that we're not taking into account, because this is a perfect demo, is that there are things in here that might not allow actual movement of water, and we call those aquithards. And so that just prevents water from moving. So what may happen is it might hit the aquitard and just sit there. And that's it.
How does this knowledge of how this works, how does this help us understand nature, or how does this influence our behavior if we're a geologist out in the field and in working as a geologist? How does this information help make decisions or help us help influence policy making or something like that?
So the biggest thing right now is that we're dealing with SGMA, or the Sustainable Groundwater Management Act, which has been put into California.
Right.
And actually many students from EES at Fresno State are actually begun to work on this as geologists and environmental scientists. And what they're going out, and they're going to certain sections of California, and they're doing testing. So they're looking to see what is the subsurface, what we call lithology. So what does it look like underneath? Are we looking at sand?
Right.
Is it rock? Is it clay?
Right.
And from those, you get a better idea of how porous the material is and how fast the water can travel.
Okay.
And so we look at that data, and then we look at the data of consumption and how it's being used for industry, for housing, for recreational use, whatever it may be. And so we have to make those calls based on what we're seeing in the actual, oh wow, I got some blood on my hands. what we're actually seeing in the ground surface
Yeah.
versus what's actually happening.
Because if let's say, if this water gets contaminated with something, or we put something into this water, but then this water is going to be something that we're drinking, we need to know what the surface is like, what that pressure is like,
Exactly.
so that we can know what is getting into drinking water or something like that.
Exactly.
It's all fabulous information, and they're teaching it at Fresno State. They're always right there on the cutting edge, and the Fresno State Physics Outreach, that's who brought us Hunter Tidd today, and they can come to your school. If you've got little ones that want to learn science, you can go on our website and you can find out how to get in touch with Professor Don Williams. All right, Hunter and Don, thank you guys so much for being here today.
Of course.
We always appreciate the lessons. Still to come here, we show you more experiments. Instead of physics, we're talking coffee. We're making an espresso martini with Mr. Black Spirits after the break.